There are a lot of reasons to want to get stronger. And I should just mention that it's not always the case that getting stronger involves muscles getting bigger. There are ways for muscles to get stronger without getting bigger. However, increasing the size of a muscle almost inevitably increases the strength of that muscle, at least to some degree. Reasons why most everyone should want to get their muscles stronger is that muscles are generally getting progressively weaker across the lifespan. So when I say getting stronger, it's not necessarily about being able to move increasing amounts of weight in the gym, although if that's your goal, what I'm about to discuss will be relevant to that, but rather to offset some of the normal decline in strength and posture and the ability to generate a large range of movement safely that occurs as we age. Heavy weights can help build muscle and strength, but they are not required. What one has to do is adhere to a certain number of parameters, just a couple of key variables, and if you do that, you can greatly increase muscle hypertrophy, muscle size, and or muscle strength if that's what you want to do. And you don't necessarily have to use heavy weights in order to do that. Something needs to happen. Certain chemicals need to be present. Certain processes need to happen, or else a tissue simply won't change itself. But if those processes and events do happen, then the tissue has essentially no option except but to change. As I mentioned at the beginning of the episode, we just tend to lose function in this neuromuscular system as we get older. And doing things to offset that has been shown again and again to be beneficial for the neuromuscular system, for protection of injury, for enhancing the strength of bones and bone density. So there are a lot of reasons to use resistance exercise that extend far beyond just the desire to increase muscle size. Because I know many of you are interested in increasing muscle size, but many of you are not. So there's an important principle of muscle physiology called the Henneman size principle. And the Henneman size principle essentially says that we recruit what are called motor units. Motor units are just the connections between nerve and muscle in a pattern that staircases from low threshold to high threshold. What this means is when you pick up something that is light, you're going to use the minimum amount of nerve to muscle energy in order to move that thing. Likewise, when you pick up an object that's heavy, you're going to use the minimum amount of nerve to muscle connectivity and energy in order to move that object. So it's basically a conservation of energy principle. If you continue to exert effort of movement, what will happen is you will tend to recruit more and more motor units with time. But let's just talk about what hypertrophy is and what strength changes in the muscle are. There are really just three ways that muscles can be stimulated to change, and those are stress, tension, and damage. Those three things don't necessarily all have to be present, but stress of some kind has to exist. Something has to be different in the way that the nerve communicates with the muscle and the way that the muscle contracts or performs that makes the muscle need to change. So this is very reminiscent of neuroplasticity in the brain. Something needs to happen. Certain chemicals need to be present. Certain processes need to happen, or else a tissue simply won't change itself. But if those processes and events do happen, then the tissue has essentially no option except but to change. So muscles move, as I mentioned, because nerves dump chemical onto the muscles, but they move because they have these things called myosin and actin filaments. But basically, along the length of the muscle, you have what's called myosin. And just think of myosin as it's kind of like a wire. It's like a bunch of beads and wires that extend across the muscle. I think that's the simplest way to describe it. And the myosin is surrounded by these little beads called actin. The way muscles get bigger is that basically the myosin gets thicker. It's a protein, right? And it gets thicker. So the way to think about muscle growth and the way to think about muscles getting stronger is that those balloons get bigger and the muscle gets thicker. How does that happen? I mean, the muscle doesn't really know anything about what's happening in the outside world. The way it happens is the neuron has to tell the muscle to get stronger. And it does that through what we call a signaling cascade. It talks to the muscle in terms of chemicals. It doesn't whisper to it or shout at it, hey, get bigger. What it does, it releases certain chemicals that within the muscle, there are certain chemicals released rather that make those balloons, as I'm referring to them, the myosin, get thicker. So let's talk about the stimulus for doing that. Everybody has imbalances in how muscles can grow. Many people who are afraid of getting too bulky, for instance, are afraid of lifting weights. But I think the research shows now that everyone of pretty much every age should be doing some sort of resistance exercise, even if that's body weight exercises, in order to offset this age-related decline in muscle contractile ability, muscle strength, etc., improve bone density. There's nothing good about getting frail and weak over time. And people who invest the effort into doing resistance exercise of some kind, whether or not it's with bands or with weights or with body weight, really benefit tremendously at a whole body level, at a systemic level, as well as in terms of muscle strength. There is a good predictor of how well or how efficient you will be in building the strength and or, if you like, the size of a given muscle. And it has everything to do with those upper motor neurons that are involved in deliberate control of muscle. You can actually do this test right now. You can just kind of march across your body mentally and see whether or not you can independently contract any or all of your muscles. So for instance, if you are sitting in a chair or you're standing, see whether or not you can contract your calf muscle just using those upper motor neurons, sending a signal down and deliberately isolating the calf muscle, okay? If you can contract the calf muscle hard to the point where that muscle almost feels like it's starting to cramp, like it hurts just a little bit, it's not going to be extremely painful, nor is it going to have no sensation whatsoever, chances are you have very good upper motor neuron to calf control. And chances are, if you can isolate that, what they call the brain or mind muscle connection, and you can contract the muscle to the point where it cramps a little bit, that you hold a decent to high potential to change the strength and the size of that muscle if you train it properly. Now, if you have a hard time doing that, chances are you won't be able to do that. There's a lot of information saying that you need to move weights that are, 80 to 90% of your 1 rep maximum, or 70%, or cycle that for 3 weeks on and then go to more moderate weights. There are a lot of paths. As what's very clear now, once you know roughly your 1 repetition maximum, the maximum amount of weight that you can perform an exercise with for 1 repetition in good form, full range of motion, that it's very clear that moving weights or using bands or using body weight in the 30 to 80% of 1 rep maximum, that is going to be the most beneficial range in terms of muscle hypertrophy and strength, so muscle growth and strength. Going above that, 85 and 90%, you're going to bias your improvements towards strength gains. This is true. And if you use weights that are in the 30% of your 1 repetition maximum, or 40% or 50%, and doing many more repetitions, of course, then you are biasing towards hypertrophy and what some people like to call muscle endurance.